Okay, a golf ball with this mass in gram, you see, you need to change to kilogram, is struck with a force that makes an angle 45 degrees with the horizontal. The ball lands 200 meters away from a flat fairway. If the golf club and the ball are in contact for 7 milliseconds, calculate the average force of impact and neglect the air resistance. Okay, so you should actually picture out what's happening here. You should draw a diagram, yeah? Okay, let's do it. So we have this is actually the ground. You know, the golf ball is we draw a golf ball there. Yeah, this is the golf ball, right? Yeah, maybe it's pinned to the ground. No, we have a holder here. Okay, it's struck with a force that makes an angle 45 degree. That means it is struck with a force. I mean, you know, when you play golf, you have the, you know, the handle. Okay, you struck the golf ball at an angle, yeah, this way. You struck it with a force 45 degree. Okay, you struck it with 45 degree. So what happened to the ball is it will launch at angle 45 degree. It will launch at an angle 45 degree. So it will launch at an angle 45 degree. It will have an initial velocity with 45 degree. You see that this is a kind of projectile motion later on. This ball will land 200 meters away on a flat fairway. So this is the flat fairway, right? This is the flat fairway. Flat fairway. It lands 200 meters away. So this is supposed to be the x displacement. That means this you know, this ball, it will travel in a projectile motion, reach back to the ground, yeah, around 200 meters away. So this one should be the let me draw it. This is the 200 meter. Okay, this is the 200 meter. This is the sx displacement. Okay. So actually, this one got two process. Yeah, I want you to see that here got two process. One is the collision. First is the collision. We use conservation of momentum. Okay, maybe you can use conservation of momentum. And then the second one here is a projectile motion. So this is a combination between the chapter for projectile motion and also the chapter for momentum and impulse. Okay, so how to do these questions? Okay, let us look more clearly what's actually happening during the collision here. Yeah, look more clearly. You know, he said that the golf club and ball are in contact for 7 milliseconds. So this one is actually the collision time. This one is not the time of flight. It's not the time of flight. It is just the collision time. This is the collision time for first process, not the second process, projectile motion. It's the collision time. We can say it's delta t. So we need to find the average force of impact. So this is the impulsive force we need to find. We need to find the impulsive force. Okay, so look carefully for this one. Yeah, look at the ball. Look at this is the golf ball and this is the club. Yeah, this is the club, and okay, the club and the ball are in contact. So this is the golf club. This is the club. This is the golf ball. Understand? This is the golf ball. This is the club. Okay, look at the first process. Yeah, I want you to look at the first process. Collision. Okay, what's actually happening during the collision? Yeah, during for the golf ball. Okay, we can use the concept of impulse. We can use the concept of impulse. impulse J. Okay, that means use the concept of impulse because this impulse will relate to the impulsive force. You understand? Impulse, but impulse on who? Impulse on the ball, the golf ball. Impulse on the ball. That means we use the change of momentum. Change of momentum of what? Of the ball. Change of momentum of the ball. Okay. And this change of momentum, we know that this impulse on the ball, this impulse on the ball, we have a second equation for the impulse, isn't it? Second equation for the impulse, which is impulsive force. That means the force on the ball. Yeah, the impulsive force multiplied by the collision time. Because it's given the collision time, isn't it? The collision time. So we need to find this impulsive force. Okay. Once we got the impulse on the ball, which is the change of momentum of the ball, we got the impulse already. We can find the impulsive force on the ball, average force of impact, which is our target. So our target is this one, the force on the ball. Okay, so very simple. So we need to find this change. First of all, we need to figure out what is the impulse on the ball, which is the change of momentum of the ball. Yeah, the golf ball. This is the golf ball. So we need to find the change of momentum of the ball. So the change of momentum means the final momentum minus initial momentum, which is mv minus mu, which is mv minus u. Okay, all of these mass of the ball, final velocity of the ball, initial velocity of the ball. Okay, so the mass of the ball is 46 grams. So we need to change to SI unit. This is 0.046 kilogram divided by 1000. Unit conversion to SI unit. So we make this. This is 0.046 kilogram, and then we need to find the final velocity of the ball. The V here, V. Do we have the V? Do we have the velocity after collision? You see, this one actually is what actually happening during the collision? It is initial. Okay, look at the initial. For the first process, collision. Initially, the ball is this is the golf ball. Initially, it is stationary. Initially, it's stationary, and then after you hit it with the force, the impulsive force, you hit it using the golf club, using the golf club, the golf club. You hit it, Then what happened to the golf ball? You hit it with an impulsive force. What an ugly word. Sorry, maybe okay, I write it properly. This is the impulsive force. Okay, you hit it with an impulsive force. Now the golf ball has a velocity. Now the ball is moving. Moving with a velocity. Isn't it? Initially is zero. So from here we know that this u here is 0 because initially is stationary. So this one is minus a 0. After you hit it with an impulsive force, with time taken, collision time 7 milliseconds. Okay, so our collision time is 7 milliseconds. 7 milliseconds. Our collision time is 7 milliseconds. So hit it, then now the golf ball has a velocity. So this is the final velocity after collision. But do we have the final velocity here? We don't have yet. We don't have yet. So we need to find out the V also. How to find out the V? This V actually is the initial velocity for the projectile motion. This velocity after collision, do you know that this is the velocity after collision, after hit by the club. After velocity after collision, after hit by the club. Okay, this velocity after collision becomes the initial velocity of ball for projectile motion. Okay, this velocity after collision hit by the club become the initial velocity of the ball for projectile motion. So now the ball has a velocity at 45 degree already for the projectile motion. So in order to find the V here, velocity after collision hit by the club, you need to find the initial velocity of the ball of the projectile motion. You need to find the U here. If you find the U here, the initial velocity for the projectile, then you can find the velocity after the collision, V here. Then we can find the impulse on the ball. Then we can find the impulsive force exerted on the ball. Understand? So now we need to move to the second process, which is the projectile motion, to find out the U. To find out the U, so that to find out this U, in order for us to find the V here. Okay? So now it becomes the U instead of V. Now become U for projectile motion. Okay, now move to the second process, the projectile motions. Yeah, so projectile. Okay, now projectile motions, we have the x displacement, isn't it? So how to do these questions? Okay, so we need to projectile motion. It has two components. It has x component and y components. So first of all, what we know about projectile motion is acceleration. Let's talk about acceleration first. Ax is always 0 because x is constant velocity. Ay is a negative g because of gravity downwards. Okay. Next is, we have the displacement. You see that? We have displacement. So this one is Sx. Sx is 200 meter. We don't have Sy. Never mind, leave it first. Oh, Sy is 0 because it returned to the ground. Sy is 0 because return to the, you see, it returned to the ground. X is 0 because it returned to ground. You see that? Because for the y component, it's just like you go up and then go back down to the same level. So the sy here is 0. You see that? The ball go up and then go back down. So the sy is 0. It returned to the ground level, return to the same level. So sy is 0. Remember that. Then what's next? We can know what else? What else can we know about this? Yeah, about the time taken should be the same. Velocity, about the initial velocity. U, okay. So ux is u cos, this u, it has two components. U has two components. It has ux and uy. Understand? Yes, ux and uy. So we need to resolve. So the x component is u cos 45, and then uy is u sine 45. Okay. Ux is positive because go to the right, positive. Uy is also positive positive because go upwards. Okay. Okay, and what else? What else we know? Yeah, the time. We need to find the time to relate to. Yeah, so the time x should be the same as time y. Okay, so now let us do the questions. Yeah. Yeah. So how to do this? Yeah. So let us start with the x component only has okay, let us start with okay, we do one by one. Yeah. Okay, let us do it. Yeah, let us do it. Oh, sorry. Hold on a second. Yeah, something's wrong. Yeah, seconds. Yeah. All right, now let's do it. Yeah. Okay, let's do the okay, wait, let me copy. Okay, yep. Now let us do the x component. Let us do the x component first. So x component is s equal to ut plus half at square. All of these we put as x component, but we know that ax0, so this one is gone. Okay, so only left with s equal to ut, s equal to ut, sx equal to uxt. So sx is already 200, and then uxt is u cos 45, and then the time taken. One thing I want you to know that time x equal to time y. Just put them as t because they have the same time. So tx and ty, tx equal to ty, and both of them equal to t. So I just put the time as t. Alright? Okay, now y component. Let's look at the y component. We also use the formula s equal to ut plus half at square. S equal to ut plus half at square. So now all of these are y components. All of these are y components. So yeah, sy is 0 because we return to the ground. And then this is u sine 45. uy is u sine 45. T, kdt. And then ay is negative g. Ay is negative g. So become negative half gt square. Okay. So this one, we have one unknowns here. We have the u we need to find out. So this one we need to do simultaneous. No, we have u and t. We don't know. Yeah, u and t. You see that? So we need to do simultaneous. We put this as equation 1, equation 2. Then we do simultaneous to find out what is u and what is t. Okay. So what we do is better is we this u we find out the u. Yeah, u in terms of t, u becomes is 200 over t cos 45. U equal to 200 over t cos 45. Then we substitute. This is our equation 1 already. Equation 1. Now substitute into equation 2. Right? Substitute into equation 2. So what do we have? So our equation 2, we have 0 equal to this one is okay, maybe I should rearrange first. Equation 2, rearrange the equation 2 first. Become half g. Let's calculate the half g. So 9.81 divided by 2, you get 4.905. So okay, so I got 4.905 t square equal to u sine 45 t. Okay, u sine 45 t. Now all right. Okay, so we got it. Okay, and this one, this one just transfer to this side, so the negative become positive. Okay, so now put in the value, the u. Yeah, put in the value, substitute this u into here. Okay, and then calculate. Yeah, into here. So we get 200 and then t cos 45. Understand? Yeah, u, and then here don't forget the sine 45, and then t. So the u here we just substitute with this. We got this and this one, and then the t can be cancelled here. T can be cancelled here, and then sine over cos become tangent, isn't it? Sine over cos become tangent, so it become 4.905 t squared equal to 200. Sine over cos is tangent 45. Tangent 45. Okay, so we can find the t square, the t. You can find the t. Let's calculate. Okay, so the time is 6.3855 second. Okay, 6.3855 second. Now we can substitute this into the equation 1 again. Substitute back into 1 and we can find the u. We can find the u. So equation 1 is yeah, look back to the equation 1. Is 200 over the time is 6. Okay. So 6.3855 cos 45. Okay, so what is our u? So our u is let's calculate, yeah. So I got my u 2945. Okay, so that's the initial velocity of the projectile. We got the initial velocity of the projectile already. Then it's easy. We got the initial velocity for projectile, yeah. This is we got 44.2945 means this is the one 44.2945. We got the initial velocity for projectile. So the initial velocity of the projectile motion, initial velocity of the ball for projectile motion is actually the velocity after collision hit by the club. Velocity of the golf ball after collision. So we got the v already. So this one is also 44. So we can write it like this. We can calculate already. We can calculate the impulse already. 0.046. You know, the velocity of the ball, after collision is the initial velocity of the ball from projectile motion. So the v here is the u here. So we just use this value into here. 44.2945 minus 0. Let's calculate the impulse. Yes, I got the impulse as 2.0375 2.0375 Newton second. That's the impulse. So now I can find impulsive force. This one, yeah. Impulsive force. I got the impulse already, so I just put this as 2.0375 equal to, okay, so 2.0375, you put it here, and then the impulsive force on the ball and the time taken, the collision time. The collision time is 7 millisecond here. Okay, so put the 7 millisecond exponent -3. Okay. So the delta t 7 millisecond we can put over here. Can find the force on the ball, impulsive force on the ball. So which is divide by 7 exponent -3. Okay, so the answer is 291.08 Newton. That's the answer. Is that correct? Almost, you see? Because why the answer a bit different? Because they round up the answer. I don't round up my answer, that's why my answer a bit different. But my answer is more accurate. Because I never round up my answer. Their answer already round up to 3 zero figure. Okay? So I got 291.08 is almost near to 293 Newton. Okay? So correct. So this is the way lah, yeah. So this question is a combination of chapters. We have projectile motion here, and also we have impulsive force over here. So it's a combination of chapter. So it's a good questions. Hope that you subscribe my channel. That's it.